future systems. Images changed how we interpret evidence, but moving images change something else. Motion feels more real than a photograph. It suggests continuity, cause, and time. In this episode, we'll look at AI video systems, how they generate motion, why movement increases believability, and where the limits still show up. A still image can be staged, but movement suggests something unfolding in real time. When we see motion, we instinctively assume physics, gravity, momentum, cause and effect. Video feels closer to witnessing than viewing. That's a powerful difference. That's why AI-generated video has a stronger psychological impact than AI-generated images. Not because the system understands motion, but because we, as viewers, associate motion with reality. Our brains are wired to trust movement, and that creates a different kind of challenge. AI video systems don't record scenes. They predict frames. Each frame is generated based on patterns the system learned about how movement usually looks. Instead of predicting the next word in a sentence, the system predicts the next image in a sequence. It estimates how pixels should change from one moment to the next. The result isn't captured motion. It's statistically plausible change. Here's what that means in practice. The system doesn't know what's moving. It doesn't understand objects, physics, or momentum. It only knows how movement tends to appear in the data it was trained on. So when you see AI-generated video, you're not watching a recording. You're watching a frame-by-frame prediction. Continuity is powerful. When motion flows smoothly, our brain assumes there's underlying structure. If a person turns their head, we assume a neck, muscles, and bones are guiding that motion. But AI doesn't simulate anatomy. It reproduces patterns of how head turning usually looks. As long as the illusion holds, we interpret it as real. But when it breaks, unnatural transitions, faces that shift slightly, objects that seem to melt or morph, the absence of structure becomes visible. These aren't bugs that will be fixed with better hardware. They're revealing something fundamental about how the system works. It's predicting appearance, not modeling reality. AI video struggles with three main things. First, consistency across time. A hand might subtly change a shape between frames. Clothing patterns might shift. Background details might drift without reason. Second, stable identities. The same person can look slightly different from one shot to the next, even within the same video. Third, long cause and effect chains. If someone picks up an object, the system might lose track of it a few frames later. These aren't random glitches. They reveal something deeper. The system doesn't track physical reality. It tracks visual probability. It doesn't know what hands do, how objects behave, or what happens when forces interact. It only knows what those things tend to look like. And that difference matters. AI video is already being used in several areas. Advertising agencies use it to create prototypes before committing to expensive shoots. Filmmakers use it for pre-visualization, testing shot compositions and camera angles. Content creators use it to generate synthetic background footage. In most cases, the generated video isn't the final output. It's a draft, a way to explore possibilities quickly. Used carefully, the technology accelerates production. You can test ideas, iterate on concepts, and see what works before investing significant resources. Used carelessly, it blurs the line between documentation and fabrication. And that's where problems start. The technology itself is neutral. The issue is how it's presented and interpreted. When AI video is applied to human faces, the stakes increase. A face in motion feels like presence. It feels like the person is there, speaking, reacting. But motion doesn't imply intention. Speech in a video doesn't mean the person actually said those words. The system doesn't know who the person is. It predicts how their face tends to move based on patterns it learned from other footage. The realism can be persuasive, even when nothing actually occurred. This isn't a distant concern. These systems exist today. They're accessible. And they're being used. Understanding how they work doesn't eliminate the problem, but it changes how you evaluate what you see. With AI video, the question shifts again. Not just, is this real, but what kind of process created this? Captured footage documents something that happened. Generated footage simulates something that could have happened. The difference is invisible if you're only looking at the output. A generated video can look exactly like captured footage. The pixels, the motion, the lighting, all of it can appear authentic. The only way to tell the difference is to understand the source. Where did this come from? Who created it? What tools were used? Visual inspection alone isn't enough anymore. This doesn't mean you should distrust every video you see. That's not practical, and it's not helpful. What it means is that context matters more than it used to. Where did this video come from? Who published it? What's the claimed source? Is there corroboration from other angles, other sources, other evidence? These questions used to be secondary. Now they're primary. The shift isn't about assuming everything is fake. It's about recognizing that visual appearance alone isn't enough to verify authenticity. That's a significant change in how we process information. AI video systems generate motion by predicting change, frame by frame. They don't simulate physics. They don't understand time. They don't know what they're depicting. Yet the illusion can feel continuous and real. Understanding that difference helps you interpret what you see without overreacting and without overtrusting. Future systems.